Right.
Alright, okay,
So
super. Alright,
on your assignment 2, we did question number
alright, okay, fine.
we did question number 2, whereby we were trying to introduce a contingent table, and we also, after defining the terms, we moved on to carrying out the hypothesis of chi-squared of independence, whereby we followed some stages. Now we are now moving on to another chi-squared test. We are going to look at question number 4b. It's another chi-squared test. We are going to follow those procedures that we did on the chi-squared test for contingents. Let me try to look on a blank page. I want to look on a blank page. I want to look on a blank
Alright,
page. So we are doing question number 4b. We want to do question number 4b. Let me try to rub these ones. I'm trying to rub everything. So on question number 4b, it is saying it is a common belief that more fatal car crashes occur on certain days of the week, such as Friday or Saturday. A sample of motor vehicle death is randomly selected for a recent year. The number of fatalities for the different days of the week are listed below. And they are saying we have a day that is Monday to Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and we've got the fatalities where we have car crashes. The fatality for Monday is 30, the fatality for Tuesday is 30, for Wednesday it's 32, for Thursday it's 32, for Friday it's 39, Saturday 36, Sunday 41. Then they are now saying at 0.01 significance level, this one is a 1% level, because 1% is a decimal, it's 0.01. So they are saying carry out a test at that significance level, at 1% significant level. Test claim that the accidents occur with equal frequency on different days. So we want to carry out a test to see if the accidents are okay with the equal frequency. That is the test that we want to carry out. Then they are saying, I think this test they were supposed to say in your test include the now hypothesis, the test statistic, critical value, conclusion, then interpretation. So this is one question. It's one question. Because when we are doing
Okay,
our test, when we are carrying out our test, we need to follow these stages. So these are part of the stages in carrying out this test. So we want to carry out the test that some we are claiming that the
alright,
accidents occur with equal frequency on different days. So as you can see, from Monday to Sunday, we have these fatalities. As the table shows, they are different. They are only equal on Monday and Tuesday. But Wednesday, Thursday, yes, Wednesday and Thursday, they are also equal. But Friday up to Sunday, they are not equal. So we want to test a claim that these frequencies okay equal. So this type of chi-squared is a chi-squared under goodness of fit distribution. It's chi-squared under goodness of fit distribution. Chi-squared, we can name it as chi-squared under goodness of fit distribution. So let me type. Let me find my keyboard. I want to type something here. So it's a test where we are saying it's a chi-squared distribution. where we want to test the goodness of it. We are testing whether the distribution is uniformly distributed. So we are saying this one is chi-squared test, and this chi-squared test is we are testing for goodness of fit, particularly on uniform distribution. That's uniform distribution. Because they are saying, the question is saying test the claim that the accidents occur with equal frequency. When you're saying equal frequency, it's like the claim is equal frequency means uniform. Equal frequency, we are testing if the data is uniformly distributed. When we are saying test the claim that the accidents occur with equal frequency, it's like we are testing whether we are testing whether the given data is uniformly distributed. So this is the test. When they're saying test the claim that the accidents occur with equal frequency on different days, we are testing whether this data is uniformly distributed.
All right.
So this is the type of chi-squared that we want to look. Goodness of fit on uniform distribution. So we have some stages. We have stages. So the stage number 1, I'm going to put my stages in star. The stage number 1 is to state the null and alternative hypothesis. We want to state the null and alternative hypothesis. You now know that the null hypothesis is represented by H naught, right? The null hypothesis is represented by H naught. So for the null hypothesis, H naught, what do we say on H naught? We are going to say that the given data that we are referring, the one in the
On
table,
H naught, the
H naught, the data is
the
uniformly distributed. That is our H naught. The data is uniformly distributed. That is our H
all
naught.
right.
Then our H1, the alternative hypothesis. Here, this one we refer this one as the null hypothesis. This is the null hypothesis. We are going to define all these terms when we are now doing hypothesis testing. We are all going to define. This is the null hypothesis. This is referred as the null hypothesis. Then we need to state the alternative hypothesis, which is represented by H1. We have what you call H1. H1 is the opposite of H naught. We are now saying the data is not uniformly. The data is not uniformly distributed. uniformly distributed. Uniformly distributed, and we are referring this one as the, are we still together? Mr. Anzo, are you there?
Yes, I'm still online, but because of my network, when you're
Okay, this is the
yes, I'm there.
okay, the alternative hypothesis. Okay, so this is the
Okay.
stages on carrying out the chi-squared for uniform distributed. Then the next stage, we want to calculate the expected frequency and the test statistic. Same applies kune yatakaita iya ye chi-squared for contingence table. So here we are calculating, let me use another, we are calculating the expected frequencies, and the test statistic. That is the second stage. So how do we calculate? We draw the table. Tunoita process here yatakaita. We have observed frequencies here. Let me use red. We have the observed frequency. And here the expected frequency.
Okay.
Let me use the right expected frequency here. Right. So from the table, these are the observed frequency. Right? The fatalities that were recorded, they are the observed frequencies. So the first one, 30, Monday, Tuesday, 30, we have 30, 30. Let me try to reduce.
Okay.
The first Monday is what? Monday is 30, right? On Tuesday, we have 30 again. And on Wednesday, what is the observed frequency on Wednesday? 32, 32. We have 32, 32. 32. 32. 39, 36. 39, 36. Then lastly, 41. So these are the observed frequencies from Monday. This is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. These were the observed frequency from the table. We just check them from the table. Then under the chi-squared of goodness test on the uniform distribution, the expected frequency is equal. Expected frequency is the same. Expected frequency is the same because we are testing whether it is uniformly distributed. So how do we find the expected frequency? We add all the fatalities, then divided by the number of days. Can we add all the fatalities? Can we add all the fatalities? Then you are saying expected frequency is equals to the total, adding all the fatalities. That is, let me take my calculator. We are adding 30 plus 30 plus 32 plus 32 plus 39 plus 36 plus 41. I'm getting 240. Then the number of days, we have 7 days. 1, 2, 3, 4, 5, 6, 7. So 240 divided by 7. And 240 divided by 7. What is 240 divided by 7? Divided by 7. I get 34.3 to 1 decimal place. 34.3 to 1 decimal place. So this 34.3 is our expected frequency. Ndo yatinge takuisa apa zvenge zvakafanana. 34.3 34.3 34.3. So this chi-squared test here uniform, my expected akafanana. We just add all the observed frequency, then the divided by the number of occurrence. Like here we have 7 days. Ndizvo ka ndofunga tiri tese nyangwe network iri kunetsa 1 2 3 4 5 6 7. So this is the expected frequency. Then next,
Yes, I'm following, sir.
Next takuchiweka zvataimboweka paya, like we want to calculate O minus
Yes,
E.
we are together.
O minus E observed minus expected frequency. Then the answer, we square it. We square the answer. Then we divide by E. Since your network is slow, I'm now forced to calculate this. Maybe you may verify. Maybe you may verify with your calculator. So here I'm saying 30 minus 30 minus 34.3. I get that one times that one, or squaring it. Wait. I'm saying 30 minus 34.3. Then I square the answer. The answer I divide by 34.3. I'm getting 0. If you can verify to 4 decimal place, I'm getting 0.53 0.5391. 0.5391. And this value is the same. This value is the same as the bottom one, because my values are yakafanana. So there's no way we can recalculate it, just paste. Same applies, the value here will be the same. Let's calculate 32 with 32 minus 34.3 equals, then I square the answer, then I divide it by 34.3. I'm getting 0.1542, 0.1542. And again, as you can see, is the same, numbers are the same as the bottom one. So I just paste, then I move on. 39 minus 34.3, I get that one, I square it, then I divide by 34.3. I'm getting 0.6440 for decimal place. I move on to the other one. 36 minus 34.3, get that. Let me calculate again. 36 minus 34.3, that one I square it, then I divide by 34.3. I'm getting 0.084 0.0843 for decimal place. Then for the last one, 41 minus 34.3, then I square it, I divide by 34.3, I get 1.3087. Right, these are my O minus E squared over E. So this is the process of calculating the test statistic. So we said, how do we find the test statistic? We find the test statistic by taking the sum of everything in green. How we find the test statistic here. This is where we are going to have our test statistic. This test statistic. This is our test statistic. This is our test statistic. We don't have an S here. It's a test statistic. So if we calculate, let's calculate to find the test statistic. We are going to sum everything. Let me add 0.5391 plus 0.5391 plus 0.1542 plus 0.1542 plus 0.6440 plus 0.0843 plus 1.3087. I'm getting 3 point, my test statistic, I'm getting 3.4, 3.4236. Are you still in the lesson, Mr. Nzo? Are you still in the lesson, Mr. Nzo? I'm alone here. Mr. Nzo has left the meeting. It's okay. Let me continue. Let me continue. Since I'm recording, I'm just continuing along. Mr. Nzo has left the meeting. It's okay, fine. So the next stage now, the next stage is to find the critical value. Let me use this space. The next stage is to find the critical value. Finding the critical value. That is our next stage. Finding the critical value. We are finding the critical value. So here we are finding the critical value. From the tables. Finding the critical value from the tables. So how do we find the critical value? We say it's chi-squared. Here we have alpha and df, where what is our df now? Degrees of freedom. How do we find the degrees of freedom under this type of test? Degrees of freedom, we are saying df is equals to number of cells. It's number of cells minus 1. And my cells in the happy. My cells, the number at which we add to get the test statistic. Ta add ama numbers mangani kuti tuane statistics. Ta add 1, 2, 3, 4, 5, 6, 7. 7 cells. So it's 7 cells minus 1. And we get our degrees of freedom is equals to 6. Now degrees of freedom is equals to 6. So the critical value, from the tables, we are going to use chi-squared. Alpha is the percentage significance. This is the alpha. 0.01. So it's 0.01 here. Here we have 0.01. 0.01, and the degrees of freedom, it's 6. Takutoenda kuma tables. Ema chi-squared 0.01 na 6. 0.01 na 6. Do this table taishandisa 0.01 na 6. Shall not 6 are here, are up. Now 0.01. Where is 0.01? 0.01. This one is 0.01. So here we have 16 point, I think 16.8. My tables, they are faint. Is this 16.8 or 16.3? I'm seeing 16.8. Where we have 6 and 0.01 is 16.8. That is our critical value, 16.8. Ndo paya patakati unogona kunyatsa draw graph rako zvakanaka tonyatsa kuona kuti zvakamira sei apa. This is the graph. Just your graph, something like this. Where here we have 0 and here we have the critical value. This is the critical value. Let me copy this one. (16.8) our critical value. So we said, how do we now conclude? We are now making a conclusion. So as you can see, my stages are tighter SI. We were trying to answer this. We have stated the null hypothesis. Tava tatostate futi ne-alternative yacho. Tatoweka test statistic. Tatoweka critical value. We are now on conclusion. Takutoita conclusion ipapo. So tisati taita conclusion, let's see kuti this value iri region ipi, iri this region. We just indicate by star. This is the test statistic. So this test statistic is in the acceptance region. Takati region inonzi acceptance region. So we indicate accept H0. That is the conclusion. Accept H0. Accept H0 is in the acceptance region. This test statistic is in the acceptance region. Ka test statistic aka ndo ka test statistic kari mu acceptance region. Takati kana kari uku we reject H0. So what is our conclusion now? Let's write our conclusion here. It's another stage. Let's make our conclusion. Conclusion. What do we say on conclusion? I'm still alone in this lesson. Ndichiri ndege here kana kuti mapinda Mr. Nzou. Mamambo enda ka?
Yes, I've rejoined network there.
Oh, network. Yeah, since I'm recording, ndaona kuti
Yes,
ndimire ka since I'm
network
recording. It's okay.
But
Saka ndango continue because
I cannot see what you are writing.
okay. So here we are now making the conclusion. The conclusion now, we are now saying on the conclusion, since what? Since the test statistic, since 3.4 236 is less than the critical value, which is 16.8. What do? We accept H0 and conclude that if we are accepting H0, what are we concluding? Conclude that the data is uniformly distributed. And conclude that the data is uniformly distributed. Because we have accepted the statement. Because we have accepted the statement. The data is uniformly distributed. So this is the conclusion. This is the conclusion. Then finally, the interpretation. So on the interpretation now. On the interpretation, right, so on the interpretation, the last we want to interpret, what does it mean to accept that the data is uniformly distributed? So the interpretation will be saying the accidents occur with equal frequency each and every day. That is the interpretation that we are concluding with. We have tested the claim to see if the data is uniformly distributed, and yes, from our results we have seen that we have to accept H0, and our H0 is saying the data is uniformly distributed. So the interpretation will be saying yes, accidents occur every day, Monday to Sunday, with the equal frequency of fatalities. That is the interpretation. So the interpretation of this, let's say interpretation, our interpretation interpretation. What are we saying on interpretation? We are saying what, let me just ignore this one. Let me copy this one. Accidents occur with equal frequencies every day. Equal frequency. Accidents occur with equal frequency of fatalities every day from Monday to Sunday. Then we are done. This is the interpretation where we say the data is uniformly distributed. So this is our test. We were trying to answer question 4B on your assignment. Question 4B on your assignment. So meaning to say we have done question number 2. Ndakakupai mamwe ma questions ekuita on this one. We also tavataita 4B. Tikaenda kutsvagirei futi ma questions ekuita this test of uniform. 4A anenge ama hypothesis, number 3 in normal tichazonyatsa kuita. So let me see if I can give you something to do on zvataita. Let me see if I can give you something. Do I have the textbook for that? Let me see if I have the textbook. Mr. Nzo. Mr. Nzo. Hello, Mr. Nzo. Oh, you've left again. It's okay, fine. So I will post your exercise on this one in the group. That's your homework for this lesson. So thank you very much.